Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we are going to continue going over some non-calculator practice questions, so questions that we could expect to see in a National 4 non-calculator exam. Today we have 4 questions this time, and these questions involve a little bit more problem solving compared to part 1, so that means that we have to think a little bit more and analyse the information that was given to us. So what I would recommend you do is that you pause the video before I presented each one of the questions and give it a go first by yourself, and then once you've done so, follow along and check to see if you got the right answer. So, let's get started.
Ooh la la!
Okay, so our first question tells us that an amusement arcade has a lighting effect in the shape of triangles with coloured lights attached, and the lighting effect can be assembled in the sections as shown below. So here we have the lighting effect for one section, and here we have it for two sections. And then for the question, part A, we're asked to complete the table, so this table right here. Part B, we're asked to write down a formula for calculating the number of coloured lights, which is denoted C in the table, when we know the number of sections S. And then finally we're told that the amusement arcade's lighting effect uses a total of 116 coloured lights, and we have to figure out how many sections are in the lighting effect. So a question like this tests our knowledge on sequences, and from this we have to figure out a sequence first of all to calculate something else. So in this case we are told that the arcade uses 116 coloured lights, so first of all we have to generate a sequence or an equation that relates both the number of sections to the number of coloured lights, and then we can figure out higher numbers such as this. So let's begin by filling out the table. We're already told that for one section we have 1, 2, 3, 4, 5, 6 coloured lights, and we can see that for when we have two sections we have 11 coloured lights, because when we add on a new section we can see here that we have 5 new lights that's added on to create two sections. So to fill out the rest of this table we have to realise this pattern, that for every time we add on a section we can see that we're adding on an extra 5 lights. So that means that for each one of these we have to add on 5 each time. So that would mean that for when we have 3 sections, the answer is going to be 11 plus 5, which would be 16. For 4 sections, that's going to be 16 plus 5, which is 21. And if we have 5 sections, that's going to be 21 plus 5, which is going to be equal to 26. Now that's all I'm going to fill out at the moment. I'm going to leave the 12 right now. And first of all, what we're going to do is move over to part B and see if we can find a formula that relates the number of coloured lights to the known amount of sections. And to write that mathematically, all that means is we want to find C as a function of S. And as I've said in a lesson we had on sequences, the way that we can get the first part of the equation is to find the step size between these jumps that we see here. And we already said that the step size is equal to 5. And then also we have to just check that the step size is consistent between each one, and we figured out, yep, that's the case. There's nothing else changing between the jump size. Each time we want to add a new section we have to add on 5 lights, so that means our step size is consistent. So that means that the first part of our equation is going to be C is equal to 5 multiplied by S, because 5 is the jump size between each of the coloured lights. And then what we have to do is check to see if this equation is correct as it is, but if not then we have to adjust it by either adding on or taking away the difference in order to get the correct value for C for a certain S. And the way that we do that is by putting in sample values for S and C into the equation that we already have. So what I'm going to do is put the value for S is equal to 1 into our equation and see what the answer for C we get. So just as an example, when we say that S is equal to 1, C is going to be equal to 5 times 1, which is equal to 5. Now this is the important part, because we see that when we use this equation here as it is, as C is equal to 5S, we see that when S is 1, C is 5, but we can see that from our table, when S is 1, C is actually 6 and not 5. So what that means is we have to accommodate this difference by adjusting our equation, and because our answer is 1 less than what it should be, because 5 is 1 less than 6, then what we have to do is add a plus 1 onto our equation. So that means that our equation is going to become c is equal to 5s plus 1. And now we can check to see if this is correct. So we can say that when s is 1, we put that into the equation. We're going to have 5 times 1, which is 5, plus 1 is 6. What about if s is 2? Well, we would have 5 times 2 is 10, plus 1 is 11, so that's correct. When s is 3, we would have 5 times 3, which is 15, plus the 1 gives us 16. So that means that we know now that this equation is correct for this sequence. So that means now to complete our table, what we can say is when s is 12, c is equal, well we know c is 5s plus 1 from our equation. So if we say when s is 12, we're going to have 5 times 12 plus 1. Well we know that 5 times 10 is 50, add another 5 is 55, so that's 5 times 11, add another 5 is 60, so that means 5 times 12 is 60, plus the 1, so that means that when s is 12, c is equal to 61. So now we've completed the table, and we now have an equation that relates the number of sections to the number of coloured lights. Now going to go on to part C and calculate how many sections are in the lighting effect when the number of coloured lights is 116. So what that really means, when C is equal to 116, we have to calculate what S is. So to put that in our equation, when C is 116, our equation is going to become 116 is equal to 5S plus 1. And now our job is to rearrange this equation to have a value for S. Now the first thing that we can do is take this plus 1 over to the other side and become minus. So that means that we're going to have 5s is equal to 116 minus 1, and 116 minus 1 is just going to be 115. So we have 5s is equal to 115, and that means that s is going to be equal to 115 divided by 5. And now if we just do this as a sum, we can say that 5 goes into 11 twice with 1 remainder over because 5 times 2 is 10, and then 5 goes into 15 3 times. So that means that our final answer for the number of sections that we have is equal to 23. Okay, so now let's move on to question 2. We are told that from the numbers 50, 93, 43, 56, 85 and 42, we have to choose for part A the two numbers which are multiples of 7, the prime number for part B, and then the number closest to a square number for part C. So this type of question is going to test our knowledge on numbers and also things like times tables and recognising patterns. So for part A, the question's technically asking us to think of the numbers which are in the 7 times table. And looking at the answer, so we have 50, 93, 43, 56, 85 and 42. Well, we know that 7 times 6 is equal to 42. And we also have 56, which is the product of 7 times 8. So that means that for part A, our answers are both 42 and 56. They are both multiples of 7. Now moving on to part B, we're asked to identify the prime number. Now remember, a prime number is a number that can only be divided by itself and 1 without leaving a remainder. So straight away we know that 56 and 42 cannot be the prime number because they're both multiples of 7. In other words, they can both be divided by 7 to give a perfect number. And other ones that we can see that it's definitely not a prime number would be 50 and 85, because we know that any number that ends in a 0 is going to be divisible by 10, and any number that ends in a 5 like 85 is going to be divisible by 5. So that means that we're left with 93 and 43. So one of these numbers is a prime number. But what I'm going to do is just test them out. So I'm going to try and divide first of all 93 by 3, because that's the most likely one that it's going to be able to divide by. So we can see that 3 goes into 9 3 times, and 3 goes into 3 once. So that means that 93 can be divided by 3. But let's just try 43 for example. We have 3 goes into 4 once with 1 left over. Then 3 into 13, well we know that's not going to be a whole number because 3 times 4 is 12. So that means we're going to have a remainder. So that means that our answer for part B is going to be equal to 43. 43 is the prime number. And then for part C, we're asked to figure out the number that's closest to a square number. I'm just going to write out the square numbers to remind us. So we have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. So what we have to do is look at these numbers and figure out which one is closest to one of these. So beginning with 50, we can see that the closest one to that is 49, so that's only a difference of 1, so that could be the contender. 93, well 93 is between 81 and 100, so it's definitely not that. 43, well the nearest to that, that's between 36 and 39, so that's not the same difference as 50. 56, again that's between 49 and 64, so it's not that. 85, well that's 4 away from 81, but that's still too big compared to 50. And 42, we see again that's between 36 and 49, so our answer is definitely 50, because 50 is only 1 away from the square number of 49, which of course is just 7 times 7. So again, questions like this are good to test our knowledge on times tables and recognising patterns, such as knowing all the square numbers and also being able to identify what is a prime number. Now, question 3, we are told that a website shows some extreme temperatures recorded on Earth, and the highest temperature recorded was 58 degrees Celsius in Libya in 1922, and the lowest temperature recorded was minus 64 degrees Celsius in Siberia in 1973, and we've been asked to calculate the difference between these two temperatures. So to think about this, first of all, I'm going to draw a temperature scale. So if we imagine here that in the middle we have 0 degrees, and everything to the right of that is going to be positive, in this case anything above 0 degrees, and anything that's negative is going to be to the left. So we can imagine we'll have the highest temperature ever recorded somewhere over here, which was the 58 degrees Celsius, and then on the negative side, so the minus temperatures, we're going to have the minus 64 degrees Celsius. And then basically what the question's asking us is to find the difference, so that means that how far away is this point from this point here? Well, we know that, of course, from minus 64 degrees to 0, the difference is 64. But then from 0 to 58, the difference is 58. So to calculate this difference, what we have to do is add the 64 and 58 together. So if we do that, we can see that we have 4 plus 8 is 12, so put the 2 down, carry the 1. Then we have 6 plus 5 is 11, carry the 1 is 12. So our answer is 122. So that means that the difference between these two temperatures is equal to 122 degrees Celsius. Now moving on to our fourth and final question of this lesson, we're asked, by starting with the smallest, write the following in order. So here we have 5 values or quantities, and we have a mixture of fractions, percentages and decimals, and we've been asked to put these values in order from the smallest to the biggest. So in order to do this, what I'm going to do is to convert all of these into the same form, and just for the sake of this video, I'm going to convert them all into decimal. So we can see that already. This is in decimal, the 0.05, and this is also in decimal, the 0.505. Well, the easiest one to begin with would be the 51%, because it's easier to convert a percentage into a decimal than a fraction into a decimal. So if we have 51% in a decimal, all we have to do is divide the 51 by 100, and that will give us our answer, and that will just give us 0.51. And now let's convert the fraction. So first of all, beginning with the 1/5, to convert that into a percentage, first of all, we would do the 1/5 multiplied by 100. And then what we would have to do is simplify this. So we know that we can simplify numbers that are on top of each other or numbers that are diagonal. And in this case, we can simplify the diagonal numbers. So we can say that how many times does 5 go into 100? Well, we know that 5 goes into 50 10 times, and 50 is half of 100. So that means that 5 must go into 100 20 times. So we can rewrite this as, if we cancel that, it becomes the 1, and that becomes the 20. Then as a percentage, 1/5 would be equal to 20%. And now to get this into a decimal, we only just divide this quantity by 100, and 20 divided by 100 is going to leave us with 0.2. So now we just have the one final fraction to do. 5 over 10 is a little bit more obvious as a percentage because 5 is half of 10. That would just mean that's 50% as a percentage, or as a fraction, or as a decimal, sorry, as I just said, it's half, which is represented as 0.5. So now we have all the quantities in decimal form. All we have to do is put them in the correct order. So starting with the smallest, it's obvious that's going to be the 0.05, so I'm just going to indicate that by a 1. Next up we have the 0.2, just going to indicate that by a 2. Then we have the 0.5 by a 3, 0.505 by a 4, and then the 0.51 by a 5. So now I've numbered all these. What I'm going to do now, just rearrange these quantities and put them in order from the smallest to the biggest. So we would have 0.05 as the smallest, and then the 1/5, and then we would have 5 over 10, then we would have 0.505, and then finally the biggest quantity out of them all was the 51%. So again, all we had to do in this case was put all of these in the same form. In this case what we did was rearrange them all into decimal instead of percentage or fraction, and then it's easier to see which is the smallest and which is the biggest. So I hope you tried some of these questions by yourself, and I hope you got the answers right. And if this video has been helpful to you in any way at all, be sure to give the video a thumbs up. But if you're still a little bit unsure in any of the answers within these questions, drop a comment down below and I'll try and explain it a little bit clearer. And if you'd like to see more content like this, be sure to subscribe to our channel or head over to our website at penguin-learning.com. Thanks again for watching, and I'll see you in the next video.